I'm sharing my screen, just a moment. Just check and let me know if the screen is visible.
Yes, sir.
Okay, so in the last lecture we were discussing about bubble sort technique, that is the first sorting technique. So to quickly revise, bubble sort technique we have total n-1 iterations, and in every iteration we try to push the largest number to the extreme right, and at the end of every iteration we try to reduce the problem by 1 from the right hand side. So in our example we had taken 7 elements. So for the 7 elements we will be having 6 iterations. So in the first iteration the largest number, that is 23, went on the extreme right. Then we reduce the problem from right hand side, so we don't consider that 23 in the second iteration. In the second iteration again we go for the same logic of pushing the largest number to extreme right. Here the number of comparisons will further be reduced. In the first iteration we were having 6 comparisons, and as we have reduced the problem from right hand side, the number of comparisons in the second iteration will be reduced from 6 to 5. At the end of second iteration, the number 21 gets pushed to the fifth index, and again now we reduce the problem by 1 from right hand side. So now 21 and 23 have already been sorted, so they will not be considered in the next step. So in the third iteration we again continue the same process, where we will have further 4 comparisons. Then fourth iteration will have 3 comparisons. Fifth iteration will have 2 comparisons, and finally the sixth iteration will have 1 comparison. Based on this, I had also asked you to solve one problem. I hope all of you have completed that and have uploaded in the notes section given for the last week. Now, while writing the logic for this particular bubble sort, we have to make use of nested for loop that we were discussing in the last lecture in the form of I and j, where the outer for loop I will talk about the number of iterations, and the inner for loop will talk about the number of comparisons that we need to make inside that iteration. So the for loop for iteration is I, and the for loop for comparison we are taking is in the form of j. So if we talk about iterations, if we have n elements, we all know that there should be n-1 iterations, right? So if we have 7 elements, we should have 6 iterations. So the for loop for I should take possible values n-1. Possible values for the loop of I should take n-1, because we should have only n-1 iterations and not n iterations. We should be having n-1 iterations. Inside that we should have some comparisons, right? So comparisons loop will be written in the form of j. Okay, so initially we have 6 comparisons, so 6 is also nothing but n-1 for us. So if I am taking n as 7, n-1 becomes 6, right? So when I try to design logic for this, all of you just have a look. I have opened dev cpp window. Just confirm if you are able to see dev cpp window. Can
Yes,
anyone
sir.
just confirm?
Yes, sir.
Yes,
Okay.
sir.
Okay. So as I told you, there will be nested for loop. One is for I and another is for j. I will be for iterations and j will be for the comparisons that we make in each iteration. While doing the comparison, what we do, we check the number present at 0 with 1, then 1 with 2, then 2 with 3, then 3 with 4, 4 with 5, and so on, right? And if this comparison gives you a phenomenon in which the left hand side number is greater than right hand side number, then you are calling a logic of swap. You all know how to do a swap, right? So we will place one thing in temp, we'll copy the other thing and then copy back, right? So that logic of swap will only be executed if the number on left hand side is greater than the number present on right hand side, and we have to continue this process, right? So let us try to write logic for this. So first we have for loop for I, which is for our iterations, which is written as for I is equal to 0, I less than n-1, I plus plus. My dear students, if I take value of n as 7 as we had in our example, what is n-1? It is 6. What is n-1? It is 6, right? So what will be the possible values for I in this loop? 0, 1, 2, 3, 4 and 5. Correct? In our example, if you remember, my dear students, what was n for us? N was 7. N was 7, right? So if n is 7, what is n minus 1? 6. N minus 1 is 6. We wanted 6 iterations. How many iterations we want? How many iterations we want then? Iterations that we want is 6. Correct? Iterations that we want is 6. Correct? So for getting those 6 iteration, how for loop I am writing? I is equal to 0, I less than n minus 1. Very important. It is not I less than n. It is I less than n minus 1. I plus plus. So if I say I less than n minus 1, so I less than 6. So the last value for I will be 5 in that case. Correct? So what will be the possible values for I? 0, 1, 2, 3, 4 and 5 means total 6 values. So we'll have total 6 iterations, correct? So total we'll have 6 iterations. So this loop gives us n minus 1 iterations. This loop gives us n minus 1 iterations. Is it understood? This loop gives us n minus 1 iteration. Now in each iteration, as I told you, there are some comparisons. There are some comparisons for which we are writing loop of j. For which we are writing loop of j. Correct? Initially, my dear students, if you observe in the Excel sheet, how many comparisons are there in first iteration? How many comparisons are there in first iteration? 6 comparisons are there. How many comparisons are there? 6. Like we have 6 iterations, we also have 6 comparisons in first iteration. So as of now, just focus on first iteration. As of now, just focus on first iteration. As of now, just focus on first iteration. So what is the maximum times j loop should run? 6 times. Correct? What is the maximum times for which the j loop should run? 6 times. So I am writing the similar condition for j also. J is equal to 0, j less than n minus 1 and j plus plus. So what is n for us? N is 7. So what is 7 minus 1? It is 6. Correct? So what is j less than 6? Maximum possible value for j is 5. So what will be possible values for j? 0, 1, 2, 3, 4, 5. So total 6 values. Correct? So what is maximum value for j? 0, 1, 2, 3, 4, 5. So this is how the j loop will capture in the blue portion which I am telling. So every time you move this j, how this j gets incremented? First j will be at this position. First j will be at this position, right? That is at 0th position, where you will try to compare this j with the next number, that is j plus 1. So what is yellow? Yellow is j. Yellow is j. Green, green is j plus 1. Yellow is j. Right now, what is value of I? I am writing value of I and j over here. What is value of I? Value of I is 0 right now. Correct? Inside that, what is value of j? Loop 0. Inside that, what is value of j? 0. Correct? So what we are trying to do is, in this case, we are trying to compare this number with this number. That is 21 with 19. So we are trying to compare the number present at j with the number present at j plus 1. So here we are doing that comparison. If the number at j is greater than the number present at j plus 1, if the number present at j, which is nothing but 21, if it is greater than the number present at j plus 1, that is 19, then only we have to write logic of swap. Correct? Otherwise the swap will not happen. So the condition is as follows: if the number present at j is greater than the number present at j plus 1, if the number present at j is greater than the number present at j plus 1, then we have to swap these two numbers. So I'm writing logic of swap. You all know how to do swap now. Okay, copy one in temp, copy back the other one. This is the logic for swap. So I'm keeping a of j in temp, then I'm making a of j as a of j plus 1, and then I'm making a of j plus 1 as temp. So this is the logic of swap, swap of a of j and a of j plus 1. As I told you, when the swap will take place, only when the left hand side number is greater than right hand side number. So how I check that left hand side number is greater than right hand side number? The condition if a of j is greater than a of j plus 1. If a of j is greater than a of j plus 1. Is it clear? So if 21, now we'll get whether a of 0 is greater than a of 1. Yes, a of 0 is greater than a of 1, and that's why we do swap of a of 0 with a of 1. That 21 and 19 got swapped from our input. 21 and 19 got swapped, right? Then the for loop of j will be incremented. Correct? Then the for loop of j. So this for loop is for our comparisons. This is for our comparisons. Correct? So if j gets incremented next time now, value of I will remain 0. Value of j will become 1. Value of j will become 1. So now j has come here. So this has become yellow now, and this has become green for us now. Because j has increment, right? So j is now at 1. And what is j plus 1 for us? It is 17. What is j plus 1 for us now? It is 17 number. Are you getting this, students? Again comparison will take place. Again j will be incremented. Again there will be a comparison between 21 and 23. There will be comparison between 21 and 23. But here swap will not take place because a of j is not greater than a of j plus 1. So swap logic will not take place, but j will be incremented. So j will now become 3. J will now become 3. J plus 1 is 4. That is 11 number. Here swap will take place. So 11 and 23 will be the output. Then j will be incremented. So now the value of j will become 4. Value of j will become 4. J plus 1 will become 5. Comparison between 23 and 9 will take place. Again, a of j is greater than a of j plus 1. So swap will take place. Left hand side and 23 will go on right hand side. Again, value of j will be incremented. And finally, the comparison between 23 and 4 will be done. 23 and 4 will be done. And swap will take place. Once swap is taken place, now value of j will increment, my dear students. What will be value of j now? 6. So the condition will be becoming false. Because what is loop of j? J should be less than n minus 1. So j cannot take value 6. So the for loop of j will finish. We will go to outer for loop. We will go to outer for loop. So in outer for loop now value of I will become 0. Sorry, value of I will become 1. Value of I will become 1. And again the value of j will become 0. Again the value of j will become 0. Again the value of j will become 0. Is it understood up till now, students? Value of j will become 0. Now again comparison will take place. Again value of j is 0, then these two numbers will be checked. So this is our yellow, that is j, and this is our green, that is j plus 1. Again next step, these two comparison will take place. And the story will continue as it is, right? So this will be 1 and 1. But my dear students, let us understand that in the next iteration, j should reduce. In the next iteration, j should reduce, right? Initially j was 6. Allowed values for j was 6. Next time it is 5, then 4, then 3, then 2, and then 1. So whatever for loop we have written in this logic, this will not get reduced. This will every time do 6 comparisons. Correct? Because if n is 7, 7 minus 1 is 6. So every time it will do 6 comparisons. So whatever statement I told you that the problem should be reduced by 1 from right hand side will not be handled if you write this type of condition. Are you getting this, my dear students? Even if you write the program in this way, still bubble sort will execute. But what will happen? There will be unnecessary checks that will be performed with the last elements also, which are already sorted, which are not going to do any kind of swaps, right? So even if you write this logic, which is written right now up till now, this will also give you correct answer of bubble sort. But what we decided is, once the largest number reaches to its extreme position, then we don't need to consider that number into sorting again. We can eliminate that number, right? So for eliminating that number, problem should be reduced by 1 from right hand side. For doing that, the scope of J should be reduced. The scope of J should be reduced, right? So how I reduce that scope of J? By adding this particular condition for my J. All of you just focus on this condition, which I am highlighting now on Dave CPP. Now instead of J less than n minus 1, which I had written earlier, now I am writing J less than n minus I minus 1. So my dear students, initially when we were in the first iteration, what was value of I? Value of I was 0. What was value of I? Value of I was 0, right? So it didn't make any impact for the condition of J, because when I do J less than n minus I minus 1, it was J less than n minus 0 minus 1. Now our incremented. In the second iteration, value of I is 1. In the second iteration, value of I is 1, right? So now when you come inside your for loop for J, this will be J less than n minus I minus 1. So what is value of I now in the second iteration? 1. So it is n minus 1 minus 1. So it is as good as n minus 2. So if your n is 7, n minus 2 is 5. So possible values for J will be 0, 1, 2, 3, 4, which is only 5 values, and that is what we wanted, that there should be only 5 comparisons. That is what only we wanted, right? So J can reach maximum till 4. And that is what we wanted. J should reach maximum till 4 means how? See how this yellow progresses, yellow and green bar. So next time yellow will come at this position. Correct? Next time green will come at this position. Yellow is A of J and green is A of J plus 1, right? This is J plus 1. Now whether yellow is allowed to go at next position? No, because here our iteration will finish. So what is maximum value of J allowed? If you see here, it is 4. Because if J is 4, then J plus 1 is 5. And that is what is happening here also. If you write the values of I and J here, correct? Here the value of I will become 4. Now, what will be the situation next time? J will become 5. But what is your condition for J? J less than n minus I minus 1. What is I? 1. So it is n minus 2. What is n? It is 7. 7 minus 2 means 5. And condition for J is less than 5. So maximum allowed value for J is only 4. So here now condition of J will become, it will fail. Value of I will again be incremented and J will again start from 0. Are you getting this? And now if the value of I is incremented, next time for sure again J will take one lesser value from right hand side, because now n minus I minus 1 will be now n minus 2 minus 1, that is n minus 3. So the maximum value for J in that case will reach only till 3. will reach only till 3. Subsequently, if we go on doing this for all the further iteration, this is how I and j will progress the way I have written. Now I am completing this, which will further give you the final answer. So these are our 6 iterations. Iteration number 1 where I is 0, iteration number 2 where I is 1, iteration number 3 where I is 2, iteration number 4 where I is 3, iteration number 5 where I is 4, and iteration number 6 where I is 5. And this is how the maximum value of j was getting reduced. Here j was taking maximum value till 5, here it was taking till 4, here it was taking till 3, here it is taking till 2, here it is taking till 1, and here only till 0. And how we control that? By simply writing n minus I minus 1. So as I got incrementing from one iteration to other iteration, the scope of j was getting reduced in the inner side loop of comparison. Now in this code, what you need to add it, you need to add the data collection above this. So you should read the array in A over here, and then you should print the array A after this for loop. So this is the main logic of bubble sort. That's it. Before this, you need to add all those decorative commands. You can include, you can write int main, then you can declare the array, you can ask user to enter the array, then you can write this for loop, and then you can again print. After writing this for loop, you can print the array and the output will be sorted output. Is it clear, my dear students? Logic of bubble sort.
Yes, sir.
Yes, sir.
Hmm? Did you find it interesting? Is this logic understood with the way I, because this you should be able to visualize this at least one sorting technique, because that's why I used this Excel, so that you will understand how the iterations and comparisons are going. And unless and until you take this example and you understand where your condition should stop, you will not be able to write this code. See, never my focus was on this code. If you see, when I was teaching you also, I never focused on code. My major focus was on actually how this thing is happening, right? So unless and until we do it on a piece of paper, we will not be able to write code for it. So it is very important for us that we should first try to do a hands-on exercise on how actually that numerical, how that problem will be solved, and then only we can go for coding of that particular example. This will improve our coding skills. Okay, so this is how the logic of bubble sort is there, which we have completed. Now complexity of this bubble sort is n square. Okay, how these complexities are getting calculated? You have another subject next year, that is computer algorithm, in which you will study in detail the analysis of these sorting techniques. But as of now, for this subject, at least you should know that what is the answer of complexity. We all have studied the definition of complexity in the first chapter, right? So the time complexity for bubble sort is n square. Now when I say n square, I cannot write square in the notepad. That's why I'm using this exponential symbol, my dear students. Okay, this is nothing but n square. N n square. Okay, the unit is number of comparison. Unit is number of comparison. So what is the work that we do inside the loop is we are trying to compare. So the complexity of the sorting techniques is defined in terms of the number of comparisons that we do inside. So it is n square. It is n square. The comparisons will not go beyond n square, because you have two for loops which are working less n minus 1 and n minus I minus 1, right? So never that is going to go beyond n square, never. So that's why it is given in the form of an upper bound. It is given in the form of an upper bound. So you can tell it is big of n square. So you can say it is big of n square. Is the bubble sort understood, my dear students?
Yes, sir.
Anyone having
Yes,
any
sir.
query, any doubt? Okay, so with this now let's sorting technique, that is selection sort. So this was our bubble sort. Let us now move to the second sorting technique, that is selection sort. Let me make the setup of Excel because the font and everything should be visible to you people. So let us now start with the second sorting technique, that is selection sort. Second sorting technique, that is selection sort. Is the screen is visible properly to you people of selection sort? Yes, students.
Yes, sir.
Yeah.
Yes.
So
Yes,
let
sir.
us, yeah. So first let us see the philosophy of selection sort. What was the philosophy of bubble sort? Bubble sort used to take n minus 1 iteration, and in every iteration it was trying to push the largest number to the extreme right of the input, and after every iteration we were reducing the problem by one from right hand side. This was the philosophy of bubble sort. So now let us see what is philosophy of selection sort. See, my dear students, during oral examination or during interviews, when someone asks you how bubble sort executes, some students usually answer like this: Sir, we compare first two numbers. Then, if the first number is greater, then we do swap. Then, second number is compared with third number. Then, sir, if the second number is greater, then we do swap. Then, sir, we do this for first iteration. Then, sir, in second iteration, again we compare first number with second. See, we are not here to explain all Ramayana and Mahabharata to the examiner or to the interview panel member. So we have to be very precise in writing our answers. We should be very precise in explaining our answers. So we should not give stories. We should not give stories. Okay. So that's why these statements I had given you at the start. So these are our philosophy statements for this sorting techniques. So if anyone asks you about what is bubble sort or how bubble sort executes, this is how, and not telling the story that compare first two number and then compare. See, in order to execute this philosophy, that is the logic that we write. You are not asked to explain the logic verbally. If someone asks you to explain logic, better you write it on a piece of paper. Okay, but don't spell out. While spelling out, your answer should be very precise. It should be crisp during oral examinations also and during the interviews also. So this is how you will explain that if someone asks you how bubble sort executes, you should tell that bubble sort takes n minus 1 iteration. In every iteration, it will try to push the largest number to the extreme right of the input. And after every iteration, the problem is getting reduced by one from right hand side. This is how in the crisp manner we will be able to explain it. Is it clear, my dear students? Similarly, now let us see what is the philosophy statement of our selection sort. So selection sort, what it does is, my dear students, it works very similar, but in a reverse way of bubble sort. In bubble sort, what we were doing is we were focusing on the largest number, and that largest number we were trying to push to the extreme right. But the focus in selection sort is towards the smallest number. The focus in the selection sort is towards the smallest number. Okay, so let us write the philosophy statement first. Selection, so all of you can make this note in your notebook also. Selection sort takes n minus 1 iterations. So like bubble sort, selection sort also takes n minus 1 iteration. In every iteration, we pick the smallest number from the input and place it in its appropriate position. What is the second statement? In every iteration, we pick the smallest number from the input. So in bubble sort, as I told you, our focus was on the largest number, right? But here the focus is on smallest number. So if I pick the smallest number from my input, I'll try to place it in its appropriate position. What will be the appropriate position for the smallest number? The first position, which is zeroth index for the first iteration. Right? Now, my dear students, if I have placed the smallest number on the left hand side, do I need to consider that number again in my solution? No. So if I give you 7 numbers, okay, so for 7 numbers again selection sort will have 6 iterations, correct? So in first iteration, we will pick the smallest number from the given input. How to pick? I'll explain you the logic. But suppose we find that smallest number. We have to place that number in position. What is appropriate position of the smallest number? It will be the first position, that is 0th index. So we'll place that number over there. Once we place that number and when we proceed to the next iteration, that is second iteration, do I need to consider again that smallest number on the left hand side? No, because now I should focus only on those remaining 6 numbers. Correct? So here now the problem will be reduced by 1 from left hand side. Problem will be reduced by 1 from left hand side after each iteration. Is it understood, my dear students? In case of bubble sort, the problem was getting reduced by 1 from right hand side, but in case of selection sort, the problem is getting reduced by 1 from left hand side, because now if the smallest number has reached its appropriate position, I don't need to consider again that. Then in remaining 6 numbers, I'll find smallest number. It will go in second position. Then again the problem will be reduced by 1. So I'll be remaining with only 5 numbers. In those 5 numbers, I'll again find the smallest number. It will reach third position. Then again I don't need to consider these 3 numbers. Then I will be remaining with 4 numbers. In those 4 numbers, again I will find the smallest number. Correct? If I do this for n minus 1 times, the only remaining number will be the largest number, which will automatically reach the last position. It was also happening in case of bubble sort, right? So we need to do this step only for n minus 1 times. So if we do this for n minus 1 iterations, our original array will be sorted. Our original array will be sorted. Is the philosophy statement clear, my dear students, for selection sort?
Yes, sir.
Yeah. So let us take an example. So this will be more clear for us. So we'll come back over here. Let us take an example. So I am taking. Okay, I'll take some example over here. 14, 17, then 9, then 7, then 15, and let me take 10. 1, 2, 3, 4, 5, 6, 7. So these are my 7 numbers. So for me, the given total number of elements are 7. Okay, total number of elements are 7. How many iterations will be there? As I told you, how many iterations will be there? N minus 1. How many iterations will be there? Will be there. So iterations. So these are our given 6 numbers. These are our given 6 numbers. Now in iteration number 1, my dear students, what will happen? What is the statement given? In every iteration, we pick the smallest number. See what is the statement, students? We pick the smallest number. So picking means directly we have to pick and place. It is not pulling, it is picking. See, in case of bubble sort, we were doing push. Push means we were doing a swap every time. Every time. It was not like I found the largest number and that only one time I did a swap. No, I did it from left hand side to right hand side. But here it is not like pulling the smallest number. Here it is picking the smallest number. So swap will happen only at the end. So I have to pick the smallest number. So with respect to this input, my dear students, with respect to this input, okay, so if I tell you these are my indices 0, 1, 2, 3, 4, 5 and 6, these are my indices, right? So Just hold on 1 minute. This is my original input and these are my index. So my dear students, what will be the first smallest number that will be picked? 7. And we have to place that 7 in its appropriate position. So what will be the output of first iteration? There will be a swap taking place between 7 and 14. Will be a swap taking place between 7 and 14. The rest numbers will remain as it is. This is output of first iteration. Because this number is identified as the smallest number in the first iteration. Did you understand this, my dear students? First iteration. This is my iteration number. Okay. This is my iteration number that I am writing. Yes, can you confirm, my dear students? Did you understand this? In first iteration, I pick the smallest number. What is the smallest number in the first iteration? 7 from the given input. And place it in its appropriate position. What is the appropriate position for 7? It should be first position, that is 0th index. So I did a swap between 7 and 14. Is it clear? Now, how did I find that 7? You need to write some logic, my dear students. I'll tell you that logic. Don't worry. But did you understand the output of first iteration? Can you confirm? Anyone has any doubt? Yes, my dear students, am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay,
Yes.
I'll tell you how to find that smallest number. Okay, but right now what I'm trying to explain is just understand the picking process. Okay, how to find that number is the next story. I'll explain you that story also. But at the end of first iteration, I have to pick the smallest number. So I picked that 7 and I swapped it with 14. Now my problem is getting reduced by 1 from left hand side. So I don't need to consider this 7 now, henceforth. Correct? So in the second iteration, this 7 will not be considered. In second iteration, 7 will not. So now what will be my problem? My problem will be only this much part. That is 17, 9, 14, 15, 16 and 10. Now in second iteration, I'll find the smallest number. What is the smallest number that I find in the second iteration? What will be the answer? 9. What will be the answer? 9. Correct? So 9 has to be placed in its appropriate position. So what swap will take place, my dear students? Can anyone tell me?
17 and 9.
Correct. 17 and 9 will be swapped. 17 and 9 will be swapped. Correct. Very good. The rest numbers I keep as it is. So 9 also has reached its appropriate position now. So we don't need to consider this 9 also in the next iteration. So in the third iteration now, I'll be remaining with only 5 numbers. I'll be remaining only with this 5 numbers, that is 17, 14, 15, 16 and 10. Are you getting this, students? Now, what is the smallest number that will be picked? 10. Correct. What is the smallest number that will be picked? It will be 10. Then now what swap will happen, my dear students? Can anyone tell me?
17 and
17,
10.
17 and 10. Absolutely correct. So this 10, 14, 15, 16 and 17. Okay. Now, my dear students, you may feel my problem is solved. No. No. I told you this story in bubble sort also. See, the logic will continue till end. The logic will continue till end. Are you getting this? Because for any random numbers, you may get answer quickly, but iteration should run. Now, once you do swap between 7, 9 and 10, these 3 are already sorted. So this will not be considered in the fifth iteration. Now in the fifth iteration, the problem will have 14, 15, 16, 17, right? What is the smallest number that will be identified?
14.
14 will be identified. Very good. 14 will be identified. Now, my dear students, do I need to do a swap between 14 and 14? Not required, right? We can save those three statements also. See, when you find the smallest number, when you find the smallest number, and if that smallest number is already in its appropriate position, then we don't need to write that swap statements also. Are you getting this? But we need to first check whether it is already present in its appropriate position. So the statements of swap can be eliminated from our logic, but that check has to be performed. How to write it in logic, we are going to discuss this in next lecture. But as of now, let us understand this, that we don't need to swap 14 with 14. It is a useless statement, right? Swapping 14 with 14. That doesn't make any sense. So that logic should not run. Like we were swapping 7 with 14 initially, then we were swapping 9 with 17, then we were swapping next time 10 with 17. Correct? Likewise, I don't need to swap now 14 with 14. Okay, so now in the next step, these four elements are already sorted. So next smallest element will be identified, will be in the form of 15. Again, I don't need to swap 15 with 15. Correct? So 7, 9, 10, 14, 15, 16 and 17. So till 15 already now it is sorted for us, confirmed. Next time smallest will be identified in the form of 16, 7, 9, 10, 14, 15, 16 and 17. Till 16 now everything is sorted. So this becomes our final answer. So how many iterations we have? When till 16 everything sorted becomes, and when we write that answer, that becomes final answer, because we don't have next iteration, because largest number already has reached its appropriate position. You don't need to tell that 17 is the smallest in the remaining one, because one number is only remaining now. Is it clear, my dear students, this story, this numerical of selection sort up till now?
Yes, sir.
Is this much part understood to all students?
Yes, sir.
Okay. Now see, major task is to find that smallest number. Major task is to find that smallest number. If you get numerical to solve, this is how you are going to solve. Okay, the way I have written only. Here the number of steps looks very less, because in bubble sort there was a push. Here there is just a pick. So in less steps this problem gets solved. But while writing logic, there is a lot of headache that we need to take, that we have to find that smallest number. So how to find that smallest number? See, for finding that smallest number, I will maintain one variable called as mean. I will maintain one variable called as mean. What is this mean? This mean is the index of that smallest number. This mean is the index of that smallest number. When I say index means what? This 0, 1, 2, 3, 4, 5, 6. Okay. So now my dear students, in first iteration, I have to start from somewhere. So I'll assume that the first number is smallest number. Initially, I'll assume that first number is smallest number. How I assume that? By writing mean as 0. Are you getting this, my dear students? Initially, I assume mean as 0. Then I compare A of mean with A of 1. What I compare? I compare A of mean. What is A of mean? A of 0. That is 14. That I compare with A of 1. What is A of 1? 17. Whether do I need to change the value of mean? No, because A of 1 is not less. So I'll keep my mean as 0 only. Again, I'll proceed. I'll check A of mean with A of 2. I'll check A of mean with A of 2. Again, do I need to change the value of mean? Whether A of 0 is less than, whether A of 2 is less than A of mean? Yes. Here now I find that it's less than mean as 2. So I'll make mean as 2. Because up till now, in this first three numbers, I find that now the number present at 2 is smaller. I again proceed. I compare the number of A of 3 and A of mean. Whether A of 3 is less than A of mean. Whether A of 3 is less than A of mean. Whether A of 3 is less than A of 2. Yes, 7 is less than 9. That's why I'll change the value of mean to 3. That's why I'll change the value of mean to 3. Again, I'll continue. I'll check whether A of 4 is less than A of mean. Whether A of 4 is less than A of mean. Whether 15 is less than 7. No, I'll not change mean. I'll again continue. Whether A of 5 is less than A of mean. Whether A of 5 is less than A of mean. Whether 16 is less than 7. No, I'll not change mean. Again, I'll continue. 6 is less than A of mean. Whether A of 6 is less than A of mean. Whether 10 is less than 7. No, I'll not change mean. So here my story of first iteration of finding mean finishes. And I have found the location. I have found the index of mean. That is 3. That is 3. Now I'll swap A of 3 with A of 0. Now I'll swap A of 3 with A of 0. Are you getting this, my dear students? Now next time I'll not consider this 7. Now my problem is from this position to this position. That is first position to sixth position. First index to sixth index. In this initially I'll assume my mean to be 1. Correct? In second iteration, initially I'll assume my mean to be 1. Because I don't need to consider this now. Otherwise every time you will get 7. We have decided the problem will be reduced by 1 from left hand side. So next time I am taking problem only from 17 to 10. So I assume initially my mean as 1. I assume initially my mean as 1. Is my screen visible, my dear students?
Yes, sir.
Yes,
Okay.
sir.
Okay. So I check whether A of mean is less than A of 2. Sorry, whether mean whether A of 2 is less than A of mean. Whether A of 2 is less than A of mean. Whether 9 is less than 17. Yes, I'll change the value of mean. So value of mean will become as 2. Value of mean will become as 2. Again, I'll check whether A of 3 is less than A of mean. No, value of mean will not change. Whether A of 4 is less than A of mean. No, value of mean will not change. Whether A of 5 is less than A of mean. No, value of mean will not change. Whether A of 6 is less than A of mean. No, so the value of mean will not change. Mean will remain 2. Mean will remain 2. So now swap of A of 2 and A of 1 will be done. So 9 and 17 and 9 get swapped. Next time you don't need to consider 7 and 9. Your problem is now from 17 to 10. So in this case now initially I assume my mean to be 2. Initially I assume my mean to be 2 because this is my problem space 17, 14, 15, 16 and 10. So in this problem space initial mean that I assume is at 2. Then I check whether A of 3 is less than A of mean. Checking has to start from next position, right? Because I assume 7 to be smallest and then I check this with respect to all remaining, right? And if I find a new smallest number, then I update the value of mean. This is how I am progressing. So that progressing starts from the next step. So I check whether A of 3 is less than A of mean. Yes, 14 is less than 13. So I update the value of min to 3. Again I check whether a of 4 is less than a of min. No, so min will not change. Whether a of 5 is less than a of min. Whether a of 5 is less than a of min. Whether 16 is less than 14. No, min will not change. We'll proceed. Whether a of 6 is less than a of min. Whether a of 6 is less than a of min. Yes, 10 is less than 14. 10 is less than 14. That's why the value of min will become as 6. That's why the value of min will become as 6. So a swap will take place now between a of 6 and a of 2. Swap will take place between a of 6 and a of 2. So that's why we get this as answer 7, 9, 10. Next iteration will have only 4 numbers remaining 14, 15, 16, 17. Here I'll assume initially my min as 3. Here I'll assume initial my min as 3. Then I compare whether a of 4 is less than a of min. No. Whether a of 5 is less than a of min. No. Whether a of 6 is less than a of min. No. So my min doesn't change. Min remains 3. And I don't need to swap a of 3 with a of 3 again. So my solution gets complete. In the next step, I'm remaining with only 3 numbers 15, 16, 17. Here I assume initially my min to be 4. I compare whether a of 5 is less than a of min. No. Whether a of 6 is less than a of min. No. So my min remains as 4. I don't need to swap a of 4 again with a of 4. So my this much part is solved. Next time I'm remaining with only 2 numbers 16 and 17. I assume my min to be 5 here. I compare whether a of 6 is less than a of min. No. So I don't need to swap and my 6 iterations are finished. Is this philosophy understood, my dear students? Yes. With this,
Yes, sir.
I'll give you one homework in this tabulated form where you will also write the mean. See, while writing mean, don't only write the final answer. Use a pencil and try to solve the way I was solving it. If a mean is getting changed, erase that mean and write a new mean. See, this finally in the table you will have only one answer. And looking at the numbers, anyone can tell where is the mean. In the first step, it is 3, then 2, then 6, then 3, 4, 5, right? But what is important is we should understand how that 3 got calculated. For that, initially I took it as 0, then it remained 0 till 2, then it became 2, then it became 3, right? So for that, you take a pencil and you solve for the next numerical which I am giving you as a homework. Okay, but that because that steps you should understand. Then only the logic will be more clear for you in the next lecture. Okay, or what you can do, you can write it with pen also, but you can scratch it out. Like my first value was 0, scratch it out and then make it 2, scratch it out and then make it 3. So you'll understand that how actually that mean got calculated. Is it clear? So this is how you should solve in the paper also. So instead of this writing only one value, you write it in a scratching way. Okay, do you understand how I am explaining? I'll write it over here. This is how you write it. Initially I assumed that to be 0. Then I got a new answer to my min in the form of 2. And then I got a new answer in the form of 3 for my first iteration. So this is how you write your min column in the paper, theory paper also. If you get a numerical for first iteration. Is it clear, students? In Excel, I'm not able to do this like this. That's why I'm showing it on a whiteboard. Is it clear, students?
Yes, sir.
Okay, so with
Yes,
this,
sir.
I'll give you one homework numerical. You try to solve that numerical so that selection sort will be more clear to you and the logic we'll discuss in the next lecture. Okay, just take down this problem 21, 17, 16, 9, 22, 15, 10, 14, 11. So I have given you total 9 numbers. So 9 numbers will have 8 iterations. So your problem should have 8 iterations. You should be able to demonstrate 8 different means in each of, so for each 8 iterations. We'll discuss answer for this with the logic in Wednesday's lecture. Have you taken down this problem, students? 21, 17, 16, 9, 22, 15, 10, 14 and 11. Have you taken it down, students?
Yes, sir.
Okay, let me quickly download the attendance because you will be late for the next lecture otherwise. Just hold on for a moment.